In integrating sine cubed dx, we need to apply a trig identity here. We cannot apply the power rule and integrate trig at the same time. That won't work. So we need to apply some kind of identity here that allows us to get an expression that we might be able to work with. So the trig identity I might want to try is sine squared. So if I have sine squared here, what I can do is I can use a trig identity for sine squared. Okay, so using that, looking at this piece here, we know that there's a trig identity of 1 minus cos squared. So I'm going to replace that with 1 minus cos squared. And then I have my sine squared on the outside, or sorry, my sine x on the outside. And I can then ask myself, is there a way I can integrate this? Well, a cos squared is a problem as well. However, we can now do a substitution. So before in the sine cube, we couldn't do a substitution. Now we can because we have some other expression over here that allows us to accommodate the du. So I'm going to let my u equal cos x. And that will make my du, so I end up with a du that is going to be sine x, or negative sine x, dx. And that allows me to account for that sine x dx in the original expression. So now I have a substitution. I have 1 minus u squared, and the sine x dx can be replaced with, and I'm just going to put the negative on here, negative du is equal to sine x dx. So I'm going to replace that with a negative du. I'll put the negative on the outside. So at this point, this is just a power rule integration. So this becomes negative u, double negative, so it's going to be plus u cubed over 3, and then don't forget the plus c. So now I can do my substitution back in, so I end up with negative cosine x plus cosine x all cubed all over 3, and then plus c, and this represents the integral of sine cubed.